Scientific investigations. You have most likely been puzzled by something you observed in nature. To observe is to gather information with your senses. Something you saw, heard, smelled, tasted, or touched made you ask a question. Scientists ask questions about things in nature too. Then they look for answers. Setting up an investigation. Let's say you observe a slice of bread that has become blue with mold. The bread has been lying on a warm countertop for a few days. You ask yourself a question. Does mold grow faster at warm temperatures? Then you make a prediction about the answer. A prediction is a good guess about what is likely to happen or about what is true. You decide to investigate. To investigate something is to study it carefully to answer a question about it. One way to do that is to set up a controlled test called an experiment. You put 2 slices of bread in separate plastic sandwich bags. You place one slice on a countertop in your kitchen. You place the second slice in your refrigerator. You must control all the conditions in your experiment. You must also test only one thing at a time. You are testing how temperature affects the growth of mold. So both sandwich bags must be the same. Both slices of bread must be the same too. Suppose you used a slice of wheat bread and a slice of rye bread. Then you would not know which affected the mold, temperature, or the kind of bread. Gathering and recording data. Your next job is to record data as time passes. To record means to write down. Data are facts and information. You can use numbers, words, and drawings to record data. The best place to record data is a science notebook. In this investigation, your data include temperature and time. You need some simple tools to gather this data. Clock and thermometer. Every day for 1 week you observe the bread. You record the day and time when you make each observation. You measure the temperature in the kitchen and in the refrigerator. You record these temperatures each day. Your data also include what you see when you observe the bread. Do you see the mold on the slices? If so, when do you first see mold on each slice? You record this data too. Coming to a conclusion. You study your data. Then you are ready to reach a conclusion. A conclusion is a statement about what you think your data mean. Let's say the bread on the countertop gets moldy before the bread in the refrigerator. The temperature was warmer on the counter than in the refrigerator. From these data, you conclude that bread and mold most likely grows faster at a warm temperature than a cooler one. You should repeat the investigation at least 2 more times. If bread on the countertop always gets moldy first, you can be pretty sure that the conclusion is correct. Making more predictions. A good prediction is based on knowledge and experience. You have learned something from your experiment with bread mold. If you leave bread on a countertop in the future, you can predict it will get moldy faster than it would in a refrigerator. Your investigation with bread can help you predict the answers to other questions. Will a lemon left on a counter become moldy faster than one left in a refrigerator? How about an apple, a peach? You can test your predictions by performing other scientific investigations. Lesson review. Number 1. Which one is an observation? A decision. B, an investigation. C, a taste. D, a number. Number 2. When should you record data? A, before you begin an investigation. B, during your investigation. C, after you have completed your investigation. D, never. Number 3. How do you reach a conclusion? A, by figuring out what your data mean. B, by recording your data. C, by making a prediction. D, by finishing an investigation. Number 4. Which one is a prediction? A, my dog barked yesterday when the mail was delivered. B, my dog will bark tomorrow when the mail is delivered. C, my dog barks when he is frightened. D, my dog likes to bark.